Alright, so now for this example number 3, we're going to look at special solutions, meaning that I can actually have an equation where there might be no solution, right? No values might work for C if I plug a number in, or I can have infinite solutions, meaning I can plug in any number into that C variable and it will work to make the equation true. So let's try this one, okay? And we're going to use the same steps as we did for example 2. First step, okay, I'm going to write it on the side, is to simplify, okay, my expressions on each side, okay? So sometimes that might involve using distributive property, as we have here. So I'm going to distribute 8 times the quantity inside these parentheses, so 8 times 5c, okay? And 8 times negative 2 is going to give me 40c minus 16. Okay, and then this 10 is going to distribute to 32 and also multiply and distribute to 4c. So that is going to give me 320 plus 40c. Alright, so now let's do the second part. I'm going to undo the order of operations by using SADMET to find the variable. Alright, and let's try this. So the first step is always wanting to get the variable on one side of the equation. So I have 40c here, and I want to, if this is positive, and it's only adding in terms of the like terms, okay, it's subtracting, okay, 40c minus 16, and this is positive, I want to subtract 40c on both sides, right? But this is interesting, look at this. Okay, 40c minus 40c cancels out on one side and also the other side. What? So, look, I get negative 16 equals 32. Is that true? Okay. No, it is false. Okay, this is a false statement. Alright? So that means, this equation, no matter what variable you will plug into C here, the values are never going to equal each other. So that means this equation, you would say, has no solution. Okay? No solution. If you try to cancel out the variables, right, and they cancel each other out on both sides, right? And if the values don't equal to each other, there is no solution. Right? Another way of saying that, no values, okay, of C, okay, can work here in this equation. Okay, I can plug in any value of C and it's not going to make the equation equal no matter what. Alright, so that's special solution number 1. Now let's look at the second case. Okay. So let's look at the second case over here. We have a different equation, and we're going to use the same step, right, from before, like we did in our previous two. Simplify the expression on both sides. Okay, if needed, distribute property, and I will. So, bam, distribute there, and want this, we're going to distribute there and there. Okay, so remember, if you're going to multiply by a fraction, it's the same thing as multiplying by the numerator and dividing by the denominator. So what is 20, right, going to do? It's going to be 20 over 5t, like that. And then 400, add 400 over 5, like that. Okay, when I multiply by that 1/5. Alright, let's continue to simplify that. Okay, I want to simplify that a little further. So 20 divided by 5 is going to give me 4t. And 400 divided by 5 is going to give me 80. Alright, let's see what I have over here. 4 times t is also going to be 4t, and then 4 plus 20 is also going to give me 80. Very interesting. So, if I want to get to the second step of this, right, where I use SADMET to kind of get the variable by itself, because look over here, right, I can't combine it anymore, or like terms on either side. I can't simplify either expression on both sides of the equation. So now it's time to move stuff around back and forth. If I will try to get the t on both sides of the equation, I will subtract 4t on both sides. Right? And look, they both cancel out again. But let's see what we have here. We get 80 equals 80. Alright, so that means that both sides of the equation, regardless of what quantity it is, will always equal and be the same. Okay? So let me go back and redo a couple things. Okay, so if I look at the equation before, right? If I see that there's the same quantity in the expression on both sides of the equation, that means that this is an identity. Okay, so identity means that one side of the equation is equal to the same value to the other side of the equation. Okay, this is the same as this side always from this equal sign. Alright, so let me write that out so you can see what that looks like. An expression, okay, and write this down in your notes, is the same on both sides. Okay, so it has infinitely many solutions. Okay, infinitely many solutions. What does that mean? Okay, it means that any value of t, right, that's the variable right here, of t, okay, works here. I could plug any number for t and it works. So if I had, right, if I plugged in, let me go here, right, t could equal 1, it could also equal -5, it also could equal 100, and so on, and no matter what number I plug into t, it's always going to be the same on both sides, because it's always going to be multiplied by 4 and added by 80, okay? So that is what an identity equation looks like, okay? Two expressions that are the same on both sides, meaning there's infinite solutions. I can plug in any value for t, and it will give me the same answer on both sides, making the equation always true. Okay? So, I want you to try some example problems below, and give your best shots.